Today we're going to talk about scientific notation. Now, scientific notation is just an easy way to write numbers that are really big or really small and become cumbersome when you're writing them. What you see here on this particular picture is just a guide that will help you figure out how to use these exponents and exactly what they mean. It's a valuable resource. So let's just talk about scientific notation, the basis of it. So we have a coefficient. Your coefficient, there are rules. Your coefficient has to be between the numbers of 1 and 9, can't be above 10, okay? Your base is going to always be 10, and then you have your exponent, and that will change. Your exponent explains to you how many times to move the decimal when you're trying to go into or out of scientific notation. So for example 1, we have the speed of light. Now the speed of light is 299 billion meters per second. So I want to put this into scientific notation. The first thing I'm going to do is I'm going to take this decimal and I'm going to move it over as many places as it takes me to get my value of my coefficient to be between 1 and 9. So I have 2, 3, 4, 5, 6, 7, 8. Perfect. So what I come up with is 2.9900000 meters per second. Now, when we're talking about scientific notation, when they're all zeros and there's nothing that follows those zeros, you don't really need them for scientific notation. My final answer is going to be 2.99 times 10 to the 8 meters per second. I know it's 10 to the 8 because I moved that decimal 8 spaces. And remember, I told you that your exponent is going to be what is going to tell you how many times to move that decimal. So a couple of quick rules just to try to remember. If we move the decimal to the right, we're going to have a negative exponent. So if we have a value that we're putting into scientific notation, we're going to move that decimal because we want our coefficient to be between 1 and 9, remember? So I'm going to move this 1 2 times, and that's going to give me 4.387 times 10 to the negative 2. I know that I moved it because it told me negative 2. That means I'm moving it to the right. So if we're going to move the decimal to the left, we're going to get a positive exponent or a larger number. Now, this is for actually having values that we're putting into scientific notation. So let's start with 438.7. I'm going to move that decimal point 2 spaces. And when I move it 2 spaces, I'm going to end up with 4.387 times 10 to the second. And I know that it was the second because it's a positive 2. I moved it to the left, and that gave me a larger number. So if we think about it in an opposite way, we're going to move the decimal to the left, and that's going to give us a negative exponent or a small number. Now, this is taking scientific notation out, a value in scientific notation out of scientific notation. So I have a negative 2. And I'm looking at my rule right above me. It says I need to move my decimal 2 spaces to the left, right? So I have 1 space and then 2 space. Now, there's nothing in that 2 space. That's going to be a placeholder right there. Now, in an effort to hold the place value, that decimal will go in front of that 0. So you're ending up with a 0.0438 7. It is a small number. Just general rule of thumb. There's our placeholder. It's bouncing in right there. And we know that we've added the right amount of zeros. So if we move the decimal to the right, we're going to get a positive exponent or a large number. And remember, this is taking our value out of scientific notation into standard notation. So we're going to move these decimals or this decimal 2 spaces. And I know that because my my exponent is 2, and I end up with 438.7. So for example 2, this is a really small number, 0.00690005. I want to put it into scientific notation. So I'm going to move that decimal point how many spaces? 3 spaces to the right. And if we remember our rules, we know that that's going to be a negative exponent. And we know that because that is a small number. So I end up with 6.90005 times 10 to the negative 3. Remember, I move the decimal to the right and I have a negative exponent because I started with a really small number. So for our next example, we have another small number, not quite as small as the other one, 0.00500. I'm going to take it and put it into scientific notation, move that decimal 3 spaces so I can have a value in my coefficient that's between 1 and 9, and I end up with 5.00 times 10 to the negative third, or to the negative 3. I know that it's negative 3 because I moved my decimal to the right. My original value was a really small number, and so I know that my exponent is going to be negative. So example number 4, we're going to do something a little bit different. Let's do it a little backwards from what we just did. 6.302 times 10 to the second. So I'm going to take this decimal point, I'm going to move it 2 spaces to the right. Now I'm moving it 2 spaces to the right because this exponent tells me to move it 2 spaces to the right. And I end up with 630.2. I started my value with a positive exponent, so I know that I'm going to move my decimal to the right, and I know I'm going to have a rather large number. And then just one more under the same umbrella, 5.1640 times 10 to the second. We automatically know we're moving that decimal point 2 places to the right because we've been told by that exponent, and that gives us 516.40. We move that decimal right, we have a positive exponent. We know that we have a positive exponent if we're already in scientific notation that we're going to end up with a larger number. If you have questions about scientific notation or struggling in any way, you should definitely reach out to your instructor or your tutorial center. I hope this video has helped you with a better understanding for scientific notation.